Hello everyone, welcome to another video. In this video, we are going to see how we can create parameterized tests with xUnit. Okay, parameterized tests is pretty much how can I pass in data to my tests in order for them to properly work, because sometimes when you are creating tests, there are needs that you have that require you to pass in data to those tests. You don't always want tests to have hard-coded values all the time. You want sometimes to have some dynamic nature to them. And in this video, we are going to see how we can create parameterized tests. We are going to see 4 approaches: InlineData, MemberData, ClassData, and TheoryData. Okay, we are going to see each one of those and how and when to use them. Okay, so here we have some boilerplate code. Okay, pretty much I have a library, a class library that just has one class. Okay, this class is very simple. It only has one method called total sum. Okay, and it accepts in its constructor, this class accepts 3 parameters, just 3 integers pretty much. Okay, and what we are going to do is to create parameterized tests for this class. Okay, now I've also created a library test project, okay, which I called my library test. It is an xUnit test project. Okay, so you'll see here xUnit all around. And also this starter project, of course, references my library. Okay, we're going to use the class from my library to do the testing. Okay, now the first strategy we are going to see to create parameterized tests is InlineData. Okay, so let's create a class here and let's call it my library class inline test. Okay, or inline data test, okay, to be more explicit. Okay, so we are testing my library class using InlineData. Okay, we are going to create a class for each strategy pretty much. Okay, don't ask again, sorry about this. Okay, so we are now going to create our test for this total sum method. Okay, so disregard the naming convention that I'm going to use here to create the test. That's not the purpose of this video. So I'm just going to call this inline data test underscore total sum. Okay, this is what I'm going to call it: total sum, the method we are testing, and the strategy we are following. Okay, now I need to annotate this method to be tested by xUnit, and since we are requiring tests to have input data, they need to be decorated with this theory attribute. Okay, now you'll soon see here that I have an error that says, okay, theory methods must have test data. So this is the purpose of this video, as I said. And what we are going to do now is to create the inline data test data. Okay, so how do I do that? Okay, first let's create our test without having the need for external data, for us to see how this external data can be of use. Okay, so I'll just for a second make this effect which means that I'm not interested in getting data from the outside world for my test. Okay, I'll just structure this test according to the AAA pattern. So having 3 stages pretty much: arrange, act, and assert. Okay. Here I'll create an instance of our class, so var sut. So normally this is called system under test. New, how is it called? New my library class. So new my library class. I need to import this, and in the constructor I need to pass in 3 parameters. So I will pass 1, 2, and 3. Okay. Now here I'll call in the actual method we want to use. So system under test dot total sum, and this will return the value of the sum. And here we are just going to do a simple assertion. Okay, nothing crazy. I'm expecting the sum to be 6. Okay, so 3 plus 2 plus 1 is 6. Okay, now let's run this test. Okay, we'll see that the test will be green. Okay, so the test will indeed pass, as we can see here on the screen. Okay, so why do we need data from the outside world? Okay, we need data from the outside world because this test is bounded to this data here. Okay, the test is bounded to this data here. If I want to now add 1, 2 plus 5, I would have to replace 3. And I may want to test multiple scenarios at the same time, and I cannot do this on this strategy. Okay, that's why we need test data. Okay, so now let's use InlineData. Okay, so the first thing is to use theory, which as we've seen before, indicates that hey, I want to pass data from the outside world to my test. And to use InlineData, what we need to do is to use the InlineData decorator here. Okay, and now we need to pass in the values that we are going to use inside our test. In this case, 1, 2, and 3. Okay. Now, you'll soon see an error here that there are no matching parameters for these values here. Why? Because it's not enough for me to declare the values here. I need to bind them to the test and then use them. Okay, since we are just creating 3 parameters, let's just declare them here. Okay, so element 1, int element 2, int element 3. Now what's going to happen with InlineData is that L1 will be bound to 1, as you can even see here on the ints, you see. L2 will be bound to 2, L3 will be bound to 3. So they are binded in order. Okay, and this means that now I can come here and say L1, L2, and L3. Now if I run the test, you'll see that my tests will still run successfully. Okay, now my data is just coming from the outside world. Now you may have noticed that I still have my 6 here encoded, right? This means that if I want to change this to 4, my test will fail because why? 4 plus 2 plus 1 is not 6. So another thing we normally can do with tests is to pass in the expected data here as a parameter as well, because then we can vary not only the inputs but also the outputs. Okay, so what we need to do is we need to add here another element, in this case the total sum we are expecting to be, in this case it's 6, and we need to bind here an element as well. So here will be total sum. This means that now total sum is binded to 6. Okay, I cannot use total sum because I already have it defined. Let's use total sum expected, okay? And now I can just come here to the expected and just use this. And now my tests should be green again, because we saw previously that this test was bounded to 6, and if I change any of the elements, I would have a problem. Okay. And now we can easily add more test cases here. So I want to add here, for example, 4, and this will increment to 7. I may want to add another one here, to 8, and this is 5, okay, and so on and so forth. And if I run my tests again, you will see here that they will show up. So we will have more tests added, but those tests will also be green as well. So you can see here that all my test cases were successful. Okay. So inline data is indeed a very simple way to add data to your tests. There are some problems that you might face with inline data. An example is that if instead of requiring these simple elements, you require more complex elements. I want a list of custom objects, okay? A list of objects. With inline data, it's hard for you to do this setup, okay? We have other strategies that are easier for you to do to achieve this goal, okay? And these are the ones that we are going to see next, okay? So the first strategy that we are going to see that might help us with these more complex tests is MemberData, okay? So let me clone this file here, and let us call this, instead of inline data, let's call this MemberData, okay? And we need, of course, to adjust the name here as well, MemberData, and also here adjust the test name, okay? Now, how do I define MemberData? Okay, the first thing that you need to understand is that you no longer define data here in line, okay? You need to define data in a dedicated data structure, okay? So we'll do this here on the test class, and then we will move this to a proper test data folder. But let's do this in a simple way now, for now, okay? So the data structure that you normally use to pass in things as data to MemberData is a IEnumerable of object array, okay? And how does this look like, okay? So let's define here, so static IEnumerable of object array, okay? Let's call this total sum MemberData, okay? And this will return a new list of object array, okay? And here is where we define the test data that we are going to use. Okay, we don't use them inline anymore. We have a dedicated data structure for this purpose, and this is the syntax for it, okay? Now let's add some input data, okay? So for this we need to do new array, okay? Let's add 1, 2, 3, and 6, okay? Okay, we are having here project object array. Okay. So this here is the equivalent of having this here. Okay, in terms of input data for my test. Okay. Now you may be wondering, okay, I have to return an object array because behind the scenes, the inputs of the test are treated as elements of an array. That's why we need to return an object array. Okay, because I have an array of test data, and this is my test data. Okay. Now, let's create the rest of the tests as we add them here. So 1, 2, 3, 4, and this is equal to 7. 1, 2, 3, 5, and this is equal to 8. Okay. And now comes the question, how can I use this test data with the member data? Okay. Now, you still need the theory, of course, because you want to pass in test data for your test. But here you use the member data decorator. Okay. And in order for you to bind your data structure with the test, you need to use this name of and pass in your data structure. Okay. And this will bind the data structure you have here with this part here. Okay. Now this is complaining because I have this as private. Okay, and put this as public. Okay. And now this works. Okay, so let's recap what we've done here. Okay. I don't want to use InlineData anymore. I may have complex objects to create, and InlineData is a bit clunky for that. So I want to use MemberData. The first step we need to do is to create a data structure that will host our test data. Okay. Inside this data structure, I define the inputs of my test. Okay. Here, each line here, each object array represents the input of the test, where each element of the array will be bound sequentially to the parameters of my test. Okay. And then I need to decorate my test with this member data decorator. Okay. And inside this constructor, let's say I need to pass in the name of my data structure. Okay. Now let's see this up and running. Okay. Now if I come here and I run my tests, I should be able to see them run successfully. Okay, so the tests will run successfully as they did for the inline data. Okay. And now if I expand this, you will see here that all of my tests went okay, and each test case that I wanted to test shows up here. Okay. Now what does this mean? This means that if I want to add more use cases for my test, more test cases, my test remains closed for modification, but open for extension on my data structure. Okay. So open-close principle in a different perspective, if you ask me. Okay. Now you might ask yourself, so should I have this data structure here on my test class? Well, it depends. You can have it, but normally what happens is that you should, in my opinion, you should have your test classes just with your test cases and have the test data separated from the test cases. Okay, this means that we need to move this data structure to another place. Let's do this. Okay, just to keep our test class highly focused on tests, having only the responsibility of having the test. Okay, so let's create a folder called test data. Okay, let's call it my library test data. Okay, I will create here a generic class, so an overall class called just test data. Okay. I'll make this static. Okay. And inside of this, public static here. Okay. And inside of this class, I will have my data structure. Okay. So I'll remove this data structure from here and I'll put it here. Okay. And now here where I had this, I need to have this test data. Okay. Test data dot total sum member data. Now you'll see an error here. Okay. And this error is just that when we have this data structure defined somewhere, we need to add here this member type component, and we need to specify where this is being held. Okay, what is the class where this is being held. Okay, it's just something simple that we need to do for if we have this data structure somewhere else. Okay, and now let's see that our tests still run successfully, even though we just made this test data go somewhere else. Okay. Now, as you can see, this is green. Okay. Now, what is the problem in my perspective with MemberData? Okay. And by the way, I've used MemberData extensively throughout these years. Okay. It works well. Okay. My major concern with MemberData specifically is on this data structure. Okay, it is weakly typed. Okay, you have just this object array. For me, I think it could be more interesting if it had more of a strong type to it, but that's just, you know, personal preference. As I told you, I've used this throughout the years and it works very well. Okay. Now let's use another strategy, okay? Because we can use other strategies. So instead of having this data structure, we can actually create dedicated classes that will have our test data. Okay, and the first strategy where we're going to see this is with class data. Okay, so first of all, let's duplicate this class here. Okay, this member data class, and let's call this my class data. Okay, it has my library class data, but you get the point. Okay, what matters is this class data here. Okay, and now let me just adjust the name here of my library class data. Okay, as I told you, we need to create a class that holds the test data. Okay, instead of having a data structure like we have here, just a simple data structure for our tests. We might want to create something more complex, like a class, more encapsulated, if you will. Now, how does the syntax look for class data? Let's first create the actual class. So let's just create total sum class data class. Okay. And the strange part about this is that this class needs to implement IEnumerable. Okay. IEnumerable of object array. Okay. This is a pattern you'll frequently see for these more abstract things. Everything is an object array. You're actually seeing this here as well. Okay, we need to implement the interface. Okay. Now, where in this class, where do we implement the actual data for my test? Okay, it's inside this get enumerator. Okay. Now what we need to do is to just yield return new object array, and now we pass in our data. Okay, and for simplicity's sake, I'm just going to copy this data here. Okay. Okay. And now I may add other test cases. Okay. I may add 1, 2, 3, 4, and this is 7. 1, 2, 3, 5, and this is 8. Okay. Okay. So my test data is declared inside of this get enumerator. Okay. Now, how can I use this class data? Okay. Now, we have a decorator called ClassData. Okay. And inside of this decorator, you can pass in the data source. Okay. So in this case, the data source, instead of being name of, it is defined as the type of the class that as you can see here on the constructor definition, it's the type of the class that has the data. Okay. The class that has the data. Okay. And here we need to adjust this to be ClassData test. Okay. And now if I come here and I run these tests, I should expect the tests to run successfully as well. Okay. Where is so our tests are here. Okay. My library class data test. Okay. And if you open here, you'll see our test cases here as well. Okay. Once again, you might tell yourself, and in my opinion very well, I don't want to mix test data with the tests. I need to extract this somewhere. We can just make use of this test class and have this on the same namespace. Okay, and have this as public. Okay, do the proper imports. Okay, not implementations. And then here, I already have this because I have the namespace imported here. Okay, so you and you will see here that the tests are still passing successfully. Okay, even though we put our test data in another file to segregate. Okay, what is test data? From actual tests. Okay. Now, I must be honest, I don't frequently use, it's one of those things you normally have a testing strategy and you stick with it. I think this is the worst of them all. Not this test, but the test data itself. I think it's a bit clunky. I think it looks a bit weird. It's not intuitive. And I think it's a bit hard to read. It raises more questions than it provides answers. And so this is a strategy that I don't normally go with. Okay. But we will see soon in the end of this video what are my actual recommendations. Okay, but this one is a bit weird. I don't personally use it. I think it's hard to read, and I like to go with things that are easy to read and maintainable. And I think this one here especially goes against that principle I have. Okay, so this is class data. Okay. Now let's see how things will look like with the last type of strategy we can have, which is theory data. Okay. Now once again, I'll just duplicate this class and I'll rename this, instead of MemberData, I'll rename this as TheoryData, which is our last strategy. Okay. And let's do the proper adjustments. Okay, so here instead of being member, it's TheoryData, and here is TheoryData. Okay. Now, how do I define test data for TheoryData? Okay, we follow a principle that is very similar to the ClassData, where we have a class that is dedicated for test data. So we need to define a class that holds our test data. So let me create here a class called, just for consistency's sake, let me grab the name here and adjust it just for consistency's sake. So instead of being total sum class data, it's total sum theory data. Okay. And this class will inherit from theory data. Okay. We will see what we will add here. Okay. And the data, the actual data, will be inside of the constructor. Okay. Now, what do we pass in here? We pass in the data types of the test input. So in this case, I have 4 ints. And here I just pass 4 ints. Okay. It is important, of course, that the number and data type of the inputs of your test here on TheoryData, they match the type and order that you have here. Okay, so it's very important for things to be on the same order and same types and so on. Okay, now how do I add data? Okay, inside the constructor itself, you have this add method. Okay, and you can pass your test data. Now you'll see that this add method already brings in the specified and data types and the number of data types you are expecting. Okay, in this case, 1, 2, 3, 6. This is very interesting approach if you ask me, because with my test data, nothing stops me from coming here and accidentally, in a very big test class, just making a mistake and adding an extra element, okay, as I did here, okay? And having this control, in my opinion, is very interesting because it allows for consistency and prevents you from making mistakes. Granted that, of course, you provide everything correctly here. Okay. And now we can add more test cases as we have been doing. So in this case, 4, 7, and 5, 8. Okay. Now this is how you specify test data with TheoryData. Now how can you use it? There is no TheoryData decorator, but the way you do it is actually with ClassData. Okay, ClassData, you pass in here type of, and you pass in this thing here. Okay. Okay. So this is how you pass in data from TheoryData. Okay, and if we run our tests, we should successfully see that the test cases show up and that the tests are successful. Okay, so we see them here, and the tests are green and they are all passing. Okay. Now, same strategy as before. I may want to segregate this. I don't want this here because it's a bit confusing. And I'll just go not to the global usings, but to this test class that holds my test data. Okay. I have just this here. Okay. This is on a different class. This is being used here. And if I run my tests, they should be running successfully, even though we have this separation between test data and test execution. Okay. Now we should see that tests are successful. Okay. Regardless of this separation. Okay. And this is how you use TheoryData. Okay. So you are more strongly typed. Okay. Now, which strategy of testing should I use? Okay. Well, this is my recommendation. This is what I personally use. Whenever the test is very simple, okay, and it has just 1-2 test parameters and that's it, I use InlineData. And those inputs are simple, okay? Just some primitive types and that's it. I use InlineData. I think it's easier to maintain. Just beware that this can grow a bit, but whenever there's few test parameters and they are not complex, I normally go with InlineData. It's simple. You can already see things here. And I think it does the job well. Now, for more complex scenarios, in the past, I used to use MemberData a lot. I used to use MemberData. I think it's better than the ClassData approach. I used to after some time you get used to it, but it always had that thing that, okay, it's not as strongly typed as I would like it to be, but that's just a personal preference. Okay. And currently I am more using this TheoryData. I think it looks a bit cleaner to read, and I think it shows the intent quite well in terms of, being strongly typed on the first place, and secondly, you can clearly see the test cases in order, very well defined. I personally think this is more pleasing to the eye because you separate each test case on its own class, and I think overall it makes it easier to maintain, at least from my experience and in my perspective. Okay, so simple test cases, use InlineData. More complex test cases, either use TheoryData or MemberData. I personally don't use ClassData because I think it's a bit strange. But, you do what's best for a project, but that would be my recommendation, okay? And with this, we've reached the end of this video. Okay, I would like to thank you so much for watching it, and I see you in the next one. Bye.